Today, I would like to put a little bit of cold water in the warm of the environment here, because if we were today to rethink the A350, the new one that has 52% of composite, maybe we would rethink, should we put that much? Reason is very simple, is that today we have not resolved the problems of conductivity of composites. And this is a huge problem for us in aeronautics, specifically when you have to guarantee safety, up there, which is basically if you get hit by lightning strike, how do you transmit electricity through the body down to the earth? And this is one of the major issues we have. So I can tell you today, the advantage of what the composite could have brought to us is canceled by what we had to do in order to make sure that we could ground, the airplane if we get into situations like lightning strike, excuse me. So I'm saying this because this is a real reality, okay? And both Boeing and us had to put a lot of things in there, like a grid, in top of the composite, put a copper grid that covers the entire airplane to make sure I can grind it. Yeah, and also we had to put, some cables around to do the grounding. Us a little bit less because we have a frame that is metallic that receives the panels. Boeing went fuselage, and that has created huge problems in terms of conductivity. So all what you have benefited from weight savings, you have lost it in some features that you had to put for grounding of the airplane. So
I wonder why don't you mention carbon nanotubes?
I do, because I tell you why. Because I think there is a big, huge potential for us to, instead of having that grid of copper, covering the entire airplane, if we could build in the material itself the conductivity, which I think it's possible, we would have now the real advantages, and we could do, a much better work into the composite. That's where I'm coming from. So that's point number one. Point number two, today it's cleaner, and we have some technologies that we have implemented to be much faster in terms of processing of composites to make our wings, our fuselage. But today the process is still more expensive as compared to alloys. So I think there is a lot of good potential for the next, for the nanocarbon fibers and those things to bring us what we need today. That is, to make sure that we can keep going with these composite airplanes. Because right now, I can tell you something, on the replacement of the small aircraft, we're really much debating, should we continue with composite structure, which 52% is probably the maximum, because, it's the entire structure that is made out of composite, or should we go back to the new alloys? And this is the debate we have today, because we have not seen the total benefits of what composite material can bring to us at this point. And mainly, I would say that, like I was saying before, the most blocking point for us, and maybe not for hovers, but being ships or being cars, at one point in time you have to make sure that you guarantee a cage of Faraday, to isolate the people from lightning, strikes or stuff like that. And that's a big issue for us.
Если мы будем говорить о композитных материалах, if we're going to discuss the composites to be used outside aerospace, does EADS envisions any business perceived areas of composite use beyond the aerospace industry?
Absolutely. I think in fact that we in aeronautics are a small player in terms of composites, in terms of volumes, in terms of business, as compared to other industries like IT. Today I think we are around $4 trillion of material business in the world. Out of that, 81 billion is composites. That's what we're estimating in 2015, and we are only, 3.54 billion. So we are very small.
Can you repeat the numbers?
Yeah, I would say that you have today in materials, around $4 trillion, of materials business in the world. Out of that, there is 81 billion is composites, and out of that, we are only 3.7 billion. So IT, for example, by itself is 41 billion. Everything that goes with IT technology and stuff like that. So we are a very, very small player into this. However, we are a player with high demand. We are a player.
You are not a small player. I just calculated you are about 7% of the total composite produced in the world.
Yeah, but
if I'm right.
Yes, but we're not the ones that, with that kind of volumes, we're not the ones that can lead, an entire industry. We can follow. We cannot pull. We are leaders in terms of usage. Because we're very early, and we're early adopters, even better than cars, even better than the rest of the transportation. However, in terms of looking at this, in terms of investments and improvements, we are not the ones that can lead this. That's what I'm trying to say. So, because we have a high demand, high technology demand, I think that the future resides in thermoplastics, for example, as compared to conventional resins today. So there is a lot of steps that we need to take, and there I just hope that other industries will help us, to follow us into this, because there is a real advantage. Another issues I want to mention that is inherent to the composite technologies is the recyclability. It's not easy to recycle, it's not easy to recycle composites. And another thing is, in short fibers, you also have to make sure that all health and safety issues are resolved. Okay? Because this is another issue also that you don't have, with alloys, metal alloys today. So, strong believer in composites, strong believers of potential of going forward with nano technologies that can help to go to the next steps. But I want to caution everybody that there is still a lot of ways to go as compared to 120 years of understanding of metals. That's what I wanted to say.